Let me introduce our first speaker, Tanisha, who works at the Juniper Networks as a software developer with a deep interest in technologies like cloud native. She'll be delivering a talk on unifying metrics, logs, and traces. Over to you, Tanisha.
Thanks, Humble, for the warm welcome. We'll start sharing my screen. Is it visible?
Yeah, all good, Tanisha.
Okay. So hi everyone. I'm Tanisha and I'm working right now as a software engineer at Juniper Networks. So today I will be talking about OpenTelemetry Collector, which is a very crucial part in the observability domain. So to start with, just a little introduction about me. You can connect with me on LinkedIn as well as on GitHub. I have been contributing to different projects in the Kubernetes domain, as well as the projects that are supporting Kubernetes. So moving on, we will be looking at this particular topics for today's agenda. And so coming to the main topic, observability. So before even starting with observability, we would like to know that how did we reach here, right? So in this era of distributed systems, which is basically having different types of systems spanned across regions, networks, and other zones, it sometimes becomes very difficult to keep track of all the data that is going through these systems, all the logs, metrics, events that is going through particular the systems or nodes. So that's where observability helps us. So what is exactly observability? It's basically, as it says, the measure of the internal states of a system. So you can say it's a property of a system, and you are able to observe a particular system based on what data you are getting out of the system. Now, that data can be of many types. So it can be IoT data, it can be any kind of log, it can be an events, many kinds, right? So that is what makes a system observable, and based on the uh, outputs that you're getting out of that system using any kind of tools, irrespective of that, you're able to say that, okay, we noticed this kind of issues or that kind of issues, right? So right now I told about data, but what exactly are those data? So data can be metrics, logs, events, tracing. So what does these terms mean? A metric is basically a very numerical measurement. Let's say you have something called some system which you want to check for performance issues. You are saying that a particular user is not able to reach that website. So you might want to know that what is causing that. You might want to look at some numerical values to see that, okay, the CPU or the memory is causing some issues. You would get the output out of that system and you would look, okay, this is increasing to a high value. We should try to reduce that. So that is what a metric is. A log. A log is basically a timestamp text record. It's not a numerical record, it's a text record. It can be structured, it can be unstructured also. It has different kinds of metadata as well. So that basically enables you to, you know, like monitor your system or observe your system based on what text you are getting. A trace is essentially, let's say, in this microservices architecture, there are many services which are sending requests to one system or one another node, right? So you would want to know sometimes that if to know the particular flow, how microservice is calling the other microservice, there might be some issues, some lagging in microservice A, which is sending request or any kind of data to microservice B. So that's how a trace is helpful. An event is particularly when, let's say, some event happened, like let's say a customer has visited an e-commerce website. So that customer has placed an order. Now you'd want to know that at what point of time and what order, what items were ordered by that particular customer. So that you can say is a event which you would like to keep record of and check if there is anything noteworthy or anything happening which can, affect your systems. So these were the main points in observability. Moving on. So these are some trends to show that why is observability needed and what can happen if it's not there. So the first point, as we can see that advanced observability deployments can cut down cost by 90%, right? So that's a very significant amount. And this is the data that was taken from the Enterprise Strategy Group, which is basically an IT firm. And next point is 70% of the respondents believe that unified observability, which is today's topic, that how combining all the observability data, that is metrics, logs, events, traces, or even more, can help you deliver the best experience to your customers. So they believe that 70% believe that this is possible only through unified observability. Again, this is a data from IDC, which is a consulting firm. Estimates from Honeycomb also say that if you are not properly implementing observability in your company or in your org, then that can lead up to 30% of the cloud bill, which is a very, very significant value. So coming to the next point, observability leaders report a 69% better MTTR for unplanned downtime or performance degradation. So as we can see here that the mean time to resolve any kind of issues that you are getting or any kind of root cause analysis that you are doing in your system can be 69% better if you implement proper observability in your system. Lastly, 43% of the organizations align that observability should be an ability to collect and analyze four types of telemetries, as we talked about: metrics, events, logs, traces, or even more. So moving on. So how critical is observability? So as we know, different companies are coming up, and it's not very easy to observe your system with just one set of tool, right? And you can't also have just one set of tools from a one vendor. You have to deal with different vendors. You will have to deal with different software tools, and it's not really easy to combine all those tools and check the data that is coming through all those tools. It's not very easy to integrate, which is the second point. Also, as the data, right? Which in turns translates to obviously high infra cost. You have to manage the data, you have to monitor the data, you have to raise different alerts, what is going with the data, why you are getting so much of performance issues, or when the, let's say when the traffic rises, right? Also, organizations need a deeper diagnostic data, enabling software observability to find the root cause analysis. So if you only have the tools, you can't really monitor or observe them properly. You also need to know and see that what is exactly causing these issues, or what's the microservice, let's say, that is lagging. So all this data and all these things comes under observability. If you don't have that, you will obviously, the persons or the developers will have a very hard time analyzing the root cause. So yeah, moving on. So as I say, OpenTelemetry, you can say they are the Avengers of observability. Now, OpenTelemetry is where it helps you. OpenTelemetry is an umbrella under which there are very numerous number of tools, APIs, SDKs. SDKs are basically you can integrate them in your application to send data to a particular, let's say, any other system or any other database. APIs you can obviously use as a REST API in your application to send data, different types of data, that is traces, metrics, logs, or events. And thirdly, OpenTelemetry Collector. This is I consider as the Avengers, as I say, because they are the unified form for all types of data they are coming, right? They are like getting all the data. They work independently of the vendors. From the data is coming, the data is where it's going. They combine everything into a single unified agent. So it's a very standardized open source observability framework. It's open source, and it's the second. OpenTelemetry is the second grossing cloud native project, just after Kubernetes. And this basically helps you to instrument your application once and deploy it everywhere. You just need to combine it to your, integrate to your application only once. The rest of the times you can just keep, integrating your different tools or other tools that you want to help for, monitoring or observing, right? You just need to instrument it once. intelligent and quick root cause analysis. Since you have everything in one place, it gets very easy to find the root cause. All the data is communicated by the OpenTelemetry protocol. So what is exactly OpenTelemetry protocol? This is particularly a protocol that is developed by OpenTelemetry community to have a uniform flow of data between different components. Now, how does it help? It has a single agent for logs, metrics, traces, events, and it prevents vendor lock-in, right? So let's say if you are taking tools from a vendor, right? Now you're sharing all the data or getting all the data from that particular vendor tool, but now you need to integrate it with your application. You would have to again depend on the vendor to get the APIs or SDKs. Now, let's say if you want to integrate it with some other tool, which is from some other vendor, that causes issues. Why? Because you have to change the way it's interfacing with that other tool, which is very difficult. It's not very easy to customize that part, right? So it OpenTelemetry Collector helps you with that. It creates the uniform flow and also saves the time. So traces, metrics, logs, events across 11 programming languages. You can run your observability stack independent of the vendor dependencies, as I said. You can also have single set of APIs. You don't need to depend on multiple tools for observing any kind of data in your application. So moving on. Yep. So now coming to what is the benefit of Kubernetes exactly? So it's also deployable on Kubernetes as a operator or a Helm installation. So basically it acts as a central data collection in Kubernetes because you can combine all types of data, Prometheus, Thanos, which is basically high availability Prometheus. You can combine Kafka, you can combine RabbitMQ, you can combine Jaeger, everything into that OTel collector deployed in Kubernetes. It's vendor agnostic, so it doesn't matter from which vendor you're getting it. It can be independent of that particular vendor. You can run it as a daemon set or as well as a sidecar to collect and aggregate all your data from all the pods or nodes, right? You can automatically capture metrics, logs, and traces from the application components without requiring extensive manual configuration. It doesn't require really any too much changes. You just need to set up your configuration and create a daemon set or a stateful set or a sidecar as you wish. Okay. So now coming to the architecture, right? So this is particularly the main architecture of OTel collector. So on the left side, we can see something called receivers. So what is receivers? The receivers are basically at the front face of your OTel collector pipeline, right? It receives the data from the customers or from other applications in your org, right? It can be any kind, as you can see. It can be OTLP, it can be Jaeger, it can be Prometheus. It's basically importing of data, you can say. Then in between, we see processes. Processes is optional in an OTel pipeline. If you, let's say, want to filter your data, you don't want to put everything on your receiver. You just want to filter some data, batch some data, anything, right? You can use the processors. Next comes the exporters. So exporters are basically where the data goes after the processors, right? You have to export it to, let's say, Prometheus or to, let's say, Grafana for visualization. You can also do that using the exporters. So there are some other components also, which I would like to explain here. So as you can see, this is a diagram that I created to explain some other components called extensions and connectors that are part of OpenTelemetry Collector. So receiver and exporter, we understood. Extensions are something which are not exactly in between receivers and exporters. They're independent of the data that you are getting or flowing in this pipeline. It basically helps you to check some probes in your OTel collector. Okay, whether my collector is working properly or not. Is it able to receive the data? Is it able to export the data? All those things you can check in the extension. Connectors are basically, let's say you have different kinds of deployments. You have an app cluster, you have an edge cluster, you have some cloud cluster. You want to connect all those components, you want to collect data from edge and app and send it to cloud. You want to keep separate OTel in different clusters. You can also do that. You can just create a connector between those two pipelines and connect it and send your data very easily. all this data flows through a uniform data type, that is OpenTelemetry protocol. Whenever data is received on the receiver, it is converted to the OpenTelemetry protocol by OpenTelemetry Collector itself. And when it's going through the processor, it can also be converted back to the OpenTelemetry protocol if you need to manipulate it to your data. And when it comes to the exporter, it converts it back to the exporter data type. So, yeah, any questions so far?
Hello.
Yep.
Yeah. So if I'm using the Prometheus, Grafana, Loki stack for my observability,
Yeah.
and if I want to integrate OpenTelemetry to this, what components does it replace? Like,
So, sure. Yeah, you can integrate Prometheus as a receiver if you want to consume the data from a Prometheus endpoint. For that, you particularly don't need a Prometheus installation per se. The OTel receiver itself acts as a Prometheus, you can say, scraper. And if you want to do any kind of processing, you can put a processor. If you want to export it to Grafana, you can also do that on the exporter side. And I don't think OpenTelemetry yet supports any Loki, maybe exporter or receiver. Uh, so if they do, I think you will be able to get the data through the receiver or exporter also.
so OpenTelemetry is a format for the observability data points.
Yeah,
Because
that's how the data flows actually. So while it's in the pipeline, it's an OpenTelemetry protocol format.
But you will still need these other components to consume the data.
Yeah, these three are the main components you can say. Yeah,
Okay.
you just have to plug your tools, as you can see on the architecture, on the left side or the right side or in between.
Okay, so common language for all the different types of observability tools.
Yep.
Okay.
Okay, so moving on to the demo. So just to give a context, I have actually, this is basically a Kafka receiver. I have customized the Kafka receiver to manipulate few things like I have added some custom encodings to give an overview exactly what the Kafka receiver is. So this is basically a Kafka consumer, you can say. As I said, receiver is kind of a consumer where data is imported. This has different configs like this all. So brokers is generally the Kafka broker IP where data is being consumed. Topic is the data is consumed in which topic exactly, or the producer is sending the data in which topic. Encodings are basically what type of encodings does the Kafka receiver understand? It has to understand your data, right? To convert it to OTLP format. So for that only it has different formats, as you can see. OTLP, which is the common format, Jaeger Proto, Jaeger JSON, Zipkin, raw and text as well. So, and there is also JSON. So raw text and JSON are only for data type called as logs. Rest Jaeger, Zipkin are for traces. OTLP is for everything, traces, metrics, as well as logs. And there are also different configurations called auth, as you can see, for your Kafka receiver, which you can add here. And protocol version is the Kafka protocol version that they are using, which is currently here 2.0.0. So I have changed this particular Kafka receiver to add a custom encoding. So that encoding has a different data type. It's because I have added this encoding so that I can enable my Kafka receiver that you understand my data when I give you the encoding as this, right? So for that only, I have added an encoding called custom. So this is the config map which I will be deploying. This config map basically helps to make sure that a OTel collector understands, okay, these are the receivers, exporters that I need to put in my deployment or I need to listen to or get data from, right? Receivers, as I said, is where I have defined my custom Kafka receiver. Brokers is the IP of the broker that is currently running in my system, the Kafka broker. Topic is custom data. Protocol version is default, as well as the encoding is custom, which I have added for my own data so that OTel collector understands it. Exporters are logging. Logging is basically exporter in OTel collector, which basically helps you to whatever data you are getting, it logs it onto the screen, that is std out. Prometheus remote write is a Thanos installation that I have in my local, where I will be visualizing the data. And the service is where you define that what all pipelines do you need. When I say pipelines, I mean metrics, logs, events, or traces, right? So currently I'm only concerned about the metric pipeline, and my receiver is custom Kafka, and the exporter is logging. And I will also put an exporter here for Prometheus, right? Which is basically Prometheus remote write is basically Thanos. So this particular pipeline, you just if you just keep your receivers or exporters here that don't do the plugging, you have to mention which receiver or exporter you want to use, right? So I mentioned it here. As we can see, this is particularly a config map, and this is my OTel collector deployment, which is basically a stateful set. And these all ports are exposed for different kinds of data, as I just said. And this is the service IP that I will be using for exposing the metrics, or if we want to see the logs or anything. So I will just go ahead and deploy my OTel collector. So let me check my Kafka deployment. So Kafka is running here, as we can see, and I will start the Minikube tunnel so that I can start sending, producing messages to my Kafka queue so that I can receive it from the OTel Kafka receiver. So it has started, and yeah, so we will go ahead and apply the manifest. So as we can see, our OTel receiver is up, which is a stateful set with the service IP. And let's see at the logs right now. So we can see that it says starting consumer group, which is the receiver, custom Kafka, which is our Kafka receiver, right? And the data type is metrics, which is the pipeline. And on partition 0. The exporter is also logging here, as we can see here. And now I also have a producer here, which is basically a Sarama producer. I'm listening on this particular localhost port where my broker is listening, and I will be sending the data. And my topic is custom data, which I've also mentioned in the config map here. So let's start sending our data. So this is my data type, as you can see here, and this is the ultimate structure which I will be sending as a JSON struct. I will be sending it to the OTel Kafka receiver, which I have created. So let me just, start sending the data. So as we can see, the data has been sent with timestamp this. And I will check my logs. So here we can see the data is coming, right? So how to understand the data? The metric is basically defines that what are the attributes of metrics. Now, metric attributes are something which are very specific to your metric. For example, in my case, it's basically, let's say, the data center name, or from where is it coming, right? Is it like a remote data center? Is it on-premise data center? Things like this. Values are basically my metric values. Metric names, you can see CPU usage, percentage, memory usage, bytes, right? These are the metric values. Timestamp is basically when are you sending the data. Resource name is particularly from where is your data getting generated, right? It can be some node, it can be some pod, right? So we are getting the data here. So now to show the Thanos dashboard, let's see the let me port forward the Thanos dashboard. So it's listening. Let's go and see here. So we can see that this is the Thanos dashboard where you can query the data. And let's see now, when was the timestamp? The timestamp was 2023, 31st of July, right? So let's put this data on the evaluation time. So in the evaluation time, you basically have to when did you ingest your data? When did you send your data to Thanos for it to visualize? So let me choose 31st July. Let me try sending the data now. So let me send the data again. And we receive the data on this time. Yeah, so we are getting the data. As you can see, the points here, CPU usage percentage, as well as memory usage bytes. Now, what did I type here is basically the particular label with which I'm identifying this particular Thanos data. Let me show you that in the config map. So here we can see something called external labels under the Prometheus remote write configuration. This basically helps you to identify that your data has which kind of labels so that you can identify it for, let's say, different environments, right? Dev, test, stage. I just put it for environment test. You can put any kind of label. This is totally customizable. So you can see the data here. Zoom it a bit. So here we can see at this particular timestamp with even environment test, metric attribute data center. Tenant ID is the default tenant in Thanos. As well as we can also see here the value for memory usage bytes. Yeah. Any questions so far? Okay. I hope that was helpful. This is basically the community of the collector. It's a very good and growing community. The like customizing anything there is very, very easy. So if you want to, if anyone wants to create any kind of exporter or receiver, they can easily build a custom collector from here using their tools that is provided by the OpenTelemetry Collector. It's very, very easy to add any kind of customizations as well, as I added for Kafka receiver. I just added a custom encoding as I showed to add that particular data so that Hotel Collector understands what kind of data I'm sending. So yeah, that's it from my side.
Any questions? Please feel free to unmute yourself and ask. Looks like we are good, Tanisha. So thank you, Tanisha, for an excellent presentation on unifying logs, metrics, and using the OpenTelemetry Collector. Thanks for sharing your valuable expertise and delivering such an insightful talk. Thanks a lot.
Thank you.